Hey, what's going on, folks? It's Mike here, and welcome to the Deep Programming Language series. In this lesson, I'm going to be talking about a cool tool that's going to help you share your D code around with other folks who are programming, or maybe this is just going to be a useful mechanism for you to get help. So with that said, let's go ahead and jump to our favorite webpage here, dlang.org. And I'm going to actually take you to the resources section here, this new tab over here that I don't believe we've looked at yet in this series, though I could be corrected. And I'm going to be looking at this run.dlang.io page here. So if you go ahead and click on that, you're going to see that we have some code here on the left here, and we've got a little run button on the top left here. Now, what's neat about this, or how to use this page, is a few different features. Now, these are all, of course, features that are available on the DMD compiler, or if you choose a different version of the compiler here, LDC is a popular one, or you can run some of the nightly or maybe beta releases. But the idea is you can just run your code here on the web browser. So let's go ahead and give this a run here. You'll see it takes a moment or so here, and this program doesn't generate any output. So let's go ahead and just make it a little bit more interesting here, maybe with a write line here. Let's just write out the data, modify it, and well, we get our output here. Okay, so not too crazy here as far as the actual code that's being generated. But what is interesting about this web page is your ability to share these snippets here. So what I can actually do is shorten this snippet here. I get a link here with a unique URL, copy to my clipboard, paste it in a new window here, and voila, we've got our modified sample here. So if you're sharing things like on my course webpage in the community, for instance, where you're following your D lessons, of course, that can make things more shareable. Folks can try out your stuff, or if you're on forums or asking for help, or on Discord or whatever, I think these could be really useful to be able to share these runnable code snippets and help folks reproduce behavior. So you'll want to make sure that you select the compiler that you want to use, whether it's DMD or LDC, and you can additionally pass in the compiler flags that you're using as well. Now, some other interesting things about this page here are the actual outputs. And these are where I just like to play around with the language a little bit here. So what I'm actually going to do here is let's modify this example here, just again here. And I don't know, create a struct like a vector here, something of this sort here with an X and a Y. And let's go ahead and just write out some simple program here, maybe X equals 500, Y equals X plus 700 here. And then let's go ahead and write out this program here. Let's go ahead and write out the value Y here. Now, what I'm demonstrating here with this simple program is just some of the other features that might be interesting. In fact, this is going to be kind of similar to those folks who are fans of godbolt.org. We've looked at that in my C++ series many times here. And there is a d.godbolt.org, or from the main website, you can look at your D code and actually run it and so on. And I'm waiting for them to update the compilers here. But you can choose the different releases. They've even got GDC on here. So that's another thing. I think we'll look at Compiler Explorer in another lesson. I want to focus on this particular one here. And anyways, what's interesting about run.dlang.org is, it's got some quick tools to help you just understand how the language works. So for example, these other tabs here, like ASM here, well, it'll actually dump out the assembly for you. And how I like to use this type of tool is maybe to search for the function here. Let's actually give ourselves a little function here. Maybe just something like add A and B here. Let's just return A plus B. Actually, we could infer that return type here. Let's do things sort of in a nice way. Of course, if we run it, we get to our 1200 output here. Let's look at the actual assembly here. Let's search for add function here. And you'll actually be able to find it in the assembly here. Now, it's got a lot of output here because, well, we've got the D standard library here for things like write line and some of the other part of the runtime here that's being emitted here. But if we look at this, we can find our add function here. Let me make sure I find the right one here. I've got add int right above our well, here's our actual function here. Okay, so you can kind of look at this, get an idea of the assembly. If you're using LDC, you could pass in the different arguments here, get assembly in a different, if you prefer like a output in a different form or whatever. So just something to know about. So that's one of the features here that's kind of quick to use if you just want to prototype something or maybe see how something's working here. The other things that you can do that I think are kind of interesting And let's actually, let's do one actual little thing here. If I pass in dash O, I haven't shown this for optimization. Let's actually run this here. Let's see if our program optimizes a little bit here. So 500 plus 700. Okay, so that's 1200. But let's look at the assembly again. And we've got to find our main function here. Okay, so we're going to have main a couple times in our assembly here. Here's our main function here. We've got a label here for the D main here. And this is going to be a little bit tricky to take a look at, but I happen to know that 0 for capital B 0, the hex value for that. Let's go ahead and type that in. This to hex is, in fact, 1200. Okay, so it's done some optimization here. We don't actually see the add here. In fact, let's actually just open that up so you can compare the versions. And this is how I see a lot of folks use like Godbolt, which is really fun here. Okay, so let's run it. Let's, again, see our main function here. And we should see that, again, a little bit harder to see here because we're using the hex here, but we are moving some values around and then actually writing out the value here, okay? So anyways, you kind of get the idea here. And again, it might be a little bit hard to read some of these text values, but this is the 500 here. And then we're loading that into this address. It looks like we put this in our accumulator here, EAX, and then we're adding it here using the load effective address. That's why we don't see an add. So anyways, I mean, if you know a little bit of assembly and optimization, again, the point is that, you know, and I've actually, let's actually save this in here as assembly. I don't know, something like this here. Whoops. Oh, I guess I don't have our output from before. But the point is to see that it is a, you know, you can compare the assemblies and see if you're using less instructions. So that's one way to use this tool. The other way that's kind of neat to use this tool is actually as a, you know, just for understanding how the language is working here, right? You can actually go to the AST here and, you know, see what attributes are inferred here. You know, what's the final version of this add function here? Okay, if I'm running with auto here, okay, so it's able to infer that this is pure, no throw, no GC, it's safe, int here. I mean, what if I just put in like int here, and then we went ahead and rerun this AST here, okay? Well, now we see like, yeah, explicitly, it's just a int, okay? Because that's what it told us. Remember that auto will do different inference for us. So that can be a little bit of an eye opener into like what power we get with auto. Here it is again. As far as like inferring some of these attributes here, or if you're just not sure how something's working. Again, that could be really useful if you're just writing templates and just to, again, see what the compiler is outputting here. So again, that's another reason why I like using this tool if you make like little demos like this and so on. And the final thing that I'll say here, which I think is really useful if you're a tool builder, right? If you go to the JSON output here, I mean, this could be a way to maybe build some tools here. You can actually see what the structure of things is. And again, have some sort of insight into what's going on. I mean, let's just look at the vec2, for instance. So if I find this sort of JSON data here, I have my vec2. It's a struct. Public, right? We've learned that if you've been watching this series, you know that by default, everything's public here. We can see what the actual members are. So you can imagine maybe building some tooling on top of this that might be interesting, right? If you sort of parse the program, because the DMD compiler is pretty fast, you know, you could do a output of the JSON representation, build a database, and then build your, you know, auto completion tool or whatever, or maybe do some sort of analysis on this to see like, hey, I've got this struct here. I can see what the offsets are of each of the fields that are floats here, and maybe do some sort of optimization or linting tool. So, I mean, those are just a few different ideas of what could be interesting. I think if you're watching this series overall, it's probably just more insightful to occasionally dump some code into this tool and say, okay, what's going on here? What if I put auto here, or if I have like auto ref or something like that here that you haven't seen yet because it has been covered in the series or something. If there is something that you want to see in this series, again, make sure you comment. But anyways, I think this is a really nice tool here. Again, the main point of this is that, yeah, use it. Shorten some URLs, paste some decode, share it with other folks, maybe on, again, forums if you're trying to get help. And it's just a nice way to have a formatted example that someone else who's reading your code can just go ahead and run and see what your results are. All right, folks. So with that said, that is the run.dlang.io webpage, which you can get to again from the resources. And I think it's just a good tool to know about. And over time, we'll continue to add some more tools to our arsenal to help us just understand what exactly is going on with a deprogramming language. Maybe if you're a tool builder, some things that could be useful for you to build on top of, and so on. So anyways, folks, with that said, I hope you enjoyed this lesson. And thank you, as always, for your time and attention. I'll look forward to seeing you in the next video.